All right, we're going to do the second problem. It says a saturated steam water mixture at 50% quality. So the first thing we recognize is it is at 50% quality. I know that that means on a TS diagram, it's right in the middle of the vapor dome. And then it says it's leaving a main turbine. So here's a turbine. And this is leaving a main turbine where quality equals 50%. And it gives us a mass flow rate. The rate at which it's leaving is 1 million pounds mass per hour. I'm going to let E represent my times 10. 1 e to the 6th pounds mass per hour. So there's the flow rate. Mass flow rate leaving is 1 million pounds mass per hour with a quality of 50%. And it says it's going into a condenser that's at a certain pressure, 1.6 psia, and the hot well temperature, the temperature of the water down here in the hot well after it's been subcooled, right there, is 112 degrees Fahrenheit. What is the heat transfer rate? Well, what they're really asking us is what is the BTUs per hour that energy is being deposited into the condenser? So one of the equations that we've looked at is Q dot equals mass flow rate, which we know, times enthalpy in minus enthalpy out. That's the change in enthalpy. And this unit would be BTUs per hour. So first of all, I need to go look and see what the saturation temperature is for 1.6 psia to determine if this water in the hot well is subcooled or saturated. So I grab my steam tables and I'm going to go to 1.6 psia and I see that 1.603 psia has a saturation temperature of 118 degrees. So Tsat at this pressure is 118 degrees Fahrenheit, Tsat. So I recognize 112 degree water is subcooled by 6 degrees in the hot well, which is pretty good. That's desirable. About 6 degrees would be great. But I want to look up the energy to figure out the outlet enthalpy. I need to know the enthalpy of subcooled water. I don't have subcooled tables here, but this is how we're going to use the steam tables as subcooled tables. Once I recognize that I have a subcooled water, and that's why we verified that it was subcooled, once I've recognized I have a subcooled water, I'm going to go to the H sub F at this temperature to figure out the enthalpy of the condensate. So let's go see what enthalpy of the condensate is if it's subcooled by merely treating the tables as subcooled and going to the temperature of 112 degrees. And if you go to your temperature tables, you'll see that 112 degrees come across, and the H sub F at 112 is 80.01 BTUs per pound mass. So I'm going to call that 80 BTUs per pound mass is the enthalpy of this water right here. That's the outlet enthalpy up here. So this is 80 BTUs per pound mass. Got that? The mass flow rate was 1 times 10 to the 6th pounds mass per hour. I need to get the inlet enthalpy. Well, can I look it up? If quality is 0% or 100%, I can look it up. So I can't look this up. I'm in the vapor dome. So what I have to do is another equation to figure out the inlet enthalpy of this steam that's going into my condenser. I come over here and I go, okay, the enthalpy at X is equal to the enthalpy F plus quality times H sub F G. And I know this is all occurring at 1.6 psia. See, 1.6 psia is felt right here through here, all here. This turbine in reality is sitting on top of this condenser. So the last stage turbine blade is experiencing condenser pressure. So I want to figure out the inlet enthalpy. Well, I go to H sub F at 1.6 psia. So I go to 1.6 psia, and I get an enthalpy of 86, I think. My eyes aren't that good. 86 BTUs per pound mass. 86, and I'm just going to keep the units off of it for now, but recognize these are all BTUs per pound mass. It's a specific enthalpy. Plus, quality is 50%, so I'll go 0.5. And what is H sub FG at 1.6? So I'm going to come right back to my steam tables, see 1.603, close enough, and I see H sub FG is 1,026 BTUs per pound mass. 1,026. I'm just going to crunch the numbers now in my calculator. So 50% of 1,026 is 513, and 513 plus 86 is 599 BTUs per pound mass. So my inlet enthalpy into this turbine is 599. So I need to take 599, subtract 80, which gives me 519. Everyone agree? 519 times 10 to the 6th BTUs per hour. 519 times 10 to the 6th BTUs per hour. Well, my units are in 10 to the 8th. So I'm going to turn this into 10 to the 8th. 1, 2. 2 to the left, change my exponent to an 8. My answer is 5.19 times 10 to the 8th. Our available answers, we come on down here and I see an available answer of 5.2. And it did ask approximate. They've just rounded. Answer is delta.